So here we've got a more complicated trig equation, and there's going to be a little bit of work to do before we start getting values for our solutions. Now the first thing is that we want to try and get rid of is this 2. So we'd much rather a trig equation to just be involved just the trig function itself. So we're going to divide both sides by 2. That leaves us with this. And now the second thing we want to deal with is what's inside this bracket. So it's not just a cos of x or a cos of theta, but we've got a cos of 2 theta plus 40. And to do this, we can make a substitution. So I'm going to say let x equal 2 theta plus 40. Now this will make the equation more simply, but there's one thing we've got to do straight away before we carry on and solve, which is before theta was limited between 0 and 360 degrees. Now we've just made a substitution that x is equal to 2 theta plus 40. So we need to think about what range of values x could be. Now the minimum value of theta is 0. So if x is 2 theta plus 40, the minimum value of x will be 40 degrees. And with a similar argument, if the maximum value of theta is 360 degrees, then the maximum value of x is going to be 2 lots of that plus 40, which will be 760 degrees. Now this step of changing your interval once you've made this substitution is crucial so that you don't miss any solutions at the end, which we'll see how that will work. But that done, we can basically rewrite our original equation. Cos x is equal to 1/2. So we've simplified this equation quite a bit, and now it's in the position we can start to solve it. So as per usual, we can obtain one solution by using our calculator. So inverse cos of 1/2 is 60 degrees. Now, like we've done before, we can sketch what that solution looks like. So that 60 degree solution will be in the first quadrant. And by considering quadrants, we can find the position of the other solution. So we've got a solution in the first quadrant because all trig values are positive, but we want cos values which are positive as well. So a second position will be in the fourth quadrant, again with an acute angle of 60 degrees with the x-axis. Now that we've done this, our diagram shows us how to find all the solutions. So we've got one solution of 60 degrees, and that is in our range. Now the second solution is going to be getting to this fourth quadrant, and that's going to be 300 degrees. But there are more. Because x is between 40 degrees and 760 degrees, we can go round again. So we'll get a third solution by going 360 degrees plus another 60 degrees. So that will give us a value for x of 420 degrees. And to finish off, we can get one more solution by going around once and around once again, almost to 720 degrees, but not quite. This will give us a final solution of 660 degrees. So we have 4 solutions. It's worth checking that there aren't any more solutions. If we went to 720 degrees plus another 60, that would take us out of the range of x values. Now, before we think we're completely done, we've just got 4 solutions for x, but the original equation was all about theta. So to finish off this question, we then need to think about, for each value of x, what will that make theta? Now to do this, we can consider what happened with our substitution. So this was our substitution. X was equal to 2 theta plus 40. So to work out theta, essentially what we need to do is take away 40 and then divide it by 2. This will give us values for theta. So theta will be 10 degrees if x was 60. If x was 300, we'll take away 40 divided by 2 will give us theta is equal to 130 degrees. Continuing this argument, if x was 420, we'll take away 40 divided by 2. That will give us theta is equal to 190 degrees. And finally, when x is 660 degrees, theta will equal 310 degrees. So now we've got 4 solutions for theta, and we can just do a quick check. All of those solutions fit into the original interval that theta is. So the structure of this solution is very important when you're solving these trig equations, and you should be left with all your solutions at the end.